Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to lecture of Economics of Environment and Natural Resources. Our topic for this lecture is population, resource use, and the environment, the Neo-Malthusian variations. In the previous two videos, we discussed the limits to economic growth, the Malthusian perspective, and in the other video, we discussed the limits to economic growth, the Ricardian perspective. In this lecture, we will discuss population, resource use, and the environment, the Neo-Malthusian variations or Neo-Malthusian perspective. So let's start the lecture. As like the previous two lectures, this lecture is also based on the Hussain 2004 book, The Principles of Environmental Economics. The Malthus theory has undergone several modifications. One of the modification was made by the David Ricardo. We discussed in the previous video. The Neo-Malthusian developed conceptual models incorporating not only the effects of population and resource scarcity, but also the technology and human institutions, which were not included in the Malthus theory, the theory presented by Malthus regarding the population and the economic growth and the food production, the per capita food production. This theory, the Neo-Malthusian models are comprehensive models because these models not only include the population and the resource scarcity in finding the limits to economic growth, but also the technology and the human institutions, which are very important and which were ignored in the theory of presented by Thomas Malthus. So the emphasis shifted from concern about limits to economic growth to the worries about the environmental sustainability. An analysis of the adverse effects of the human activities on natural environment is a major common characteristic of Neo-Malthusian conceptual models. The services of environment are recognized not only as a supplier of raw material and energy as a factor of production, but also as a accelerator of the waste and provider of amenities along with maintenance of life support system. It is usually expected that increased human activities would lead to increasing stress on environment, which lead to environmental degradation. It is believed, and we have seen in our practice as well, in our daily life as well, that when the human activities increases, it puts stress on the environment, and some of the activities lead to environmental degradation. It may be either due to emitting too much, and how this happens, how this environmental degradation happens. It may be either due to the emitting too much waste into environment or exploiting the natural environment to the point of approaching ecological threshold like overfishing, large-scale deforestation, and overgrazing. We discussed in the previous videos that the overfishing, the large-scale deforestation, and the overgrazing leads to an environmental problem, the tragedy of commons. So this is a concern because if degradation of environment is not restricted to the point that is considered sustainable, biophysical limits will eventually place bounds on the growth of the human activity. These will, if the environmental degradation is not stopped, it is not restricted up to the point which is sustainable, which is bearable, then the biophysical limits will finally bound the human activity, will restrict the human activity, growth of the human activity. It is this recognition of the possible biophysical limits to the economic activities that identifies Neo-Malthusians with Malthus' doctrine of the doctrine of economic growth. This issue of environmental sustainability is central to the Neo-Malthusians. They constructed models, the Neo-Malthusians, they constructed models that incorporate the variables expected to be key determinants of environmental degradation. They are little bit advanced models. These models used conceptual framework of the Ehrlich Commoner model, which we simply short we call it EH model. The EH model assumes that all human activities modify the natural environment to some extent. In simplest form, the model is can be written in the mathematical form as I equal to P cross F, where I is the environmental effect or damage, and this I can be measured by the amount of resources extracted or harvested per annum, or the total land area subjected to deforestation. Is we can express it in this form, so it is measurable, and in this equation the P is the population size. It assumes that more and more people cause more environmental damage, and there is positive correlation between the population size and environmental damage. This equation, in this equation, equation number 1, it is assumed that this I is environmental damage, the P is the population size, and it is assumed this model that with increase in the population, there is environmental degradation. Similarly, this is an index that measures the per capita impact to the environment. In this equation, it enters as simply as I by P. Equation 1 states that the total environmental impact of the human activities is the product of population size and the per capita damage to the environment. In other words, the total environmental impact is equal to the total population multiplied by average impact that each person has on the environment. Viewed this way, the EH model is indisputable mathematical identity or truism. This model is an important model, which is in which we see that the total environmental impact is equal to the population multiplied by per capita environmental damage. To get the insights from this equation number 1, it is necessary to fully examine the interrelationship between the two key variables P and per capita impact F. Let me take a shot of the equation to make it easy to explain. So this is the equation. So in this equation, this equation 1, it measures the per capita damage. So as explained, that the total environmental impact I is equal to the population multiplied by this per capita damage. To get the insights of this equation, let us study the P and F more comprehensively. To make this model more revealing and of some particular value, we examine per capita impact, the F, as a separate function that is affected by several key variables. Now we go to the insert of this details of this F, and it is assumed by the Neo-Malthusians that this F, this per capita environmental damage, this is affected by a number of other factors. So we equate this, we take it as a separate function, and say that F is equal to capital F is a function of P, C and G, whereas expand the P is the population size, while C is per capita consumption or production, and aggregate level consumption and production are assumed to be equal, measured by real per capita domestic product GDP over ratio over P over population, which is the real GDP per capita. The general expectation is that holding other factors constant, increase in per capita consumption would lead to increase in the degradation of environment per capita basis. This equation says that if the P and G are kept constant, then increase in the per capita consumption will lead to increase in the per capita environmental degradation. It is notable that a rise in the average person's income would lead not only to increased consumption, but also consumption pattern which will lead to higher levels of material and energy use. In this, so far the consumption is concerned, the consumption will increase with increase in the per capita income. But with increase in the per capita income, not only the one's consumption will increase, but also he will consume those products which have a higher material and energy intensity. In this equation number 2, let me take a screenshot of this as well. So, in equation 2, in this equation, G is the composition of inputs and outputs in an economy, expressed in terms of their impact on environment. According to the commoner, the variable G is index that measures damage in terms of per unit of output. Furthermore, it said the association between G and I is positive, since according to him, past technological modes of production and institutional settings have increasing damaging to the environment. Population is a primary factor in environmental degradation and resource depletion, the Ehrlich perspective. According to Ehrlich, population plays a primary role in explaining the impact human activities have on environment and resource use. According to him, when population grows, the total impact I increases for two reasons. We can explain it with this figure number 3. Here we see that if there is increase in the population, it will increase the environmental degradation directly. On the other hand, increase in the population, it leads to increased per capita damage due to increased population. Therefore, this increased per capita damage will also increase the environmental degradation. So this means that according to the Ehrlich perspective, the population affects the environmental population increase the environmental damage in two ways. First, the size of population P will increase. Second, for reasons of explained above, per capita impact number one, the population effect directly the environmental degradation. Secondly, per capita impact F increases with successive additions to the population. As we see in this equation number 1, equation number 2, that P is also a significant determinant of the F. So with increase in the P, the environment per capita environmental damage will increase. Therefore, according to equation 1, the total impact increases since both P and F grow, as shown in figure number 3. It is explained why the per capita damage F, an increasing function of population with the help of law of diminishing marginal return. According to him, most of the developed nations' economies are already operating at high levels of production capacity. These nations are therefore on the diminishing returns on the part of their production functions. Under these circumstances, if other factors are held constant, successive addition of people would require increased use of resources such as energy, water, fertilizer, etc. As population continued to grow, the per capita impact in terms of resource depletion and environmental deterioration would increase successively. Furthermore, the same argument can be used for agriculture sectors of most of developing countries. For most of these reasons, the agriculture sector accounts for a significant percentage of their economy, and diminishing returns would be encountered because of limited availability of farmland. Dear students, in final analysis, Ulrich and his followers would contend that a rising human population is the predominant factor in accelerating population and other resource problems in both developed and developing countries, nations of the world. There have been some empirical studies that support this hypothesis, like the Allen and Barron 1995, Peter and Holmes 1983, Rudel 1989. The population growth leads to a high rate of deforestation, both directly and indirectly. Let me correctly reference. The major weakness of this position advanced by Ulrich is that many of the factors already identified as having an effect on per capita impact P, such as per capita consumption of resources and technology, are held constant. Furthermore, no explanation is given as why these factors should be have neutral or insignificant effects on per capita damage. Thus, in the environmental damage. So, dear student, as discussed earlier, this material has been taken from the Neo-Malthusian book 2004, Principles of Environmental Economics. Thank you very much.